The Aqualunar competitors are, of course, all striving to make their technologies the one to make that next leap. And I'm happy to now show the winners. The second runner-up is Aqualunar Pure. The first runner-up is the Filtered Regolith Aqua Neutralization Kit, or FRANC, and the winner is the Sonochem system by Nika Scientific. Three very different technologies again. Aqualunar Pure is a supercritical oxidation reactor, which will first heat lunar ice to leave behind dust and rock particles, then increase the temperature and pressure further to create supercritical water, not a solid, a liquid, or a gas, but a fourth state, like a thick vapor, in which oxidation will simultaneously remove all contaminants. FRANC is a three-stage approach designed to deliver a continuous flow of drinking water. It would first heat the lunar soil in a sealed chamber to drive off volatile gases and leave a liquid mixture behind of water, methanol, and regolith fragments. The liquid is then filtered through a membrane, and the filtrate is distilled to separate the methanol from the water. Finally, the winning technology uses microwaves to defrost lunar ice, then ultrasound to break down the contaminants and provide potable water. Sonochem creates millions of tiny bubbles in the meltwater. The extreme temperatures and pressures created within the microbubbles generate free radicals, which effectively remove all contaminants. Let's hear these three winners.
My name is Edo Boek. I'm currently a professor in chemical engineering at Queen Mary University of London. We've developed the concept of water purification using a one-step concept, a process called supercritical water oxidation. We take water up to high temperatures and high pressures where water is a very thick vapor. All the contaminants will be destroyed by the supercritical water. The technology we develop for the moon, in fact, is suitable to treat the contaminants in terrestrial water. So we'll have a direct impact for the water problems we encounter today on Earth. Other projects that I've applied for, they weren't nearly as exciting as this one. This would really spark the interest of both my students and myself, and I think this is an example how it should be done.
Team FRANC is a system that's designed to purify lunar water. We're going to use ultrafiltration and a distillation process. Between us, we feel we've got a good chance of coming up with a solution that will work. The reason we thought this challenge was really interesting is not only is there the financial backing to help us develop our product, but we get access to a huge range of support. I'm looking forward to having this opportunity to build hardware that could one day in the future be operating on the moon and providing drinking water for astronauts. But over the next couple of months, I'm really looking forward to seeing our concept become a bit more of a reality and starting to test and prototype elements of our design.
My name is Lola Nika. My concept is to use the power of ultrasound to create millions of tiny, small bubbles within liquid water. These expand and collapse, creating high temperature, high pressure microreactor environment that generates free radicals and decomposes contaminants. It's really difficult to build and commercialize space technology, but with Aqualunar Challenge, they provide a platform for finding and furthering that technology with a commercial customer in the terrestrial environment. The process is really well structured to come up with a concept that is valuable to the team, even though they don't go forward, and valuable to both the space industry and the water industry.
Huge congratulations again to all of the winners, but especially Nika Scientific. Since undertaking this challenge, Nika Scientific have raised over £230,000 in investment, and Sonochem has been accepted onto a payload that will fly in 2026.